To solve another problem of Leetcode, and it's called path sum, and I'm all out of snacks, right? So in this problem we are given root of binary tree and integer, which is the target sum, and we want to return a boolean, a true, if there exists a path from a root node to leaf node, in which if we sum the values, if we add up the values from the root node to the leaf node, that sum is equal to the target sum provided. If there exists such a path, then we want to return true, else we want to return false. So the problem is pretty simple. So you can see that in this example, the target sum is 22, and if we sum 5 plus 4 plus 11 plus 2, then it is equal to 22, and therefore the output is true. If there doesn't exist any path, for example, in example number 2, the target sum is 5. So if we go to the left, the sum is 3. If you go to the right, the sum is 4. So there exists no path in which the sum of these nodes from root to leaf is equal to 5, and therefore the output is false. So that's the problem statement. The solution is on your right. As you can see, there is a function has path sum, and what we're doing here is that at first what we're doing is checking if the root, if there exists no nodes. If there are no nodes, then obviously we have to return false. Even though let's say the target sum is 0, there is no nodes, we have to return false, because 0 is still something, right? So if there exists no nodes, there's nothing, so nothing is not equal to 0, and therefore it's a false. In the next condition, we're checking if it's a leaf node. To do that, we're checking if there is no left subtree and no right subtree. That means it's a leaf node. And at the leaf node, we want to check if the target sum is equal to the value is equal to the value of or the sum of the values of nodes, right? But in this case, we're just checking if the target sum is equal to root, the value at the root. This is because we are solving this problem slightly different, because we're changing the value of target sum. If you look at the else statement, what we're doing is we're dividing it to the left subtree and right subtree by recursively calling the same function. And here what we're doing is changing the target sum. We are subtracting the current current value of any node from the target sum, and at the end, when we reach the leaf node, if the target sum is equal to 0, that means the whole sum of the values from that root to leaf node is equal to the actual initial target sum. And that's the idea we're using here, and that's why when we subtract the current value of the leaf node from the target sum, if it is equal to 0, that means the whole sum is equal to the initial target sum, and if that's the case, we want to return true. But if that's not the case, we want to return false. And at the end, we are returning left or right, because we want only one path that if at least one path exists where the sum is equal to the target sum, then the answer of this solution is true, and therefore we are using OR in this case, and that should be the solution for this problem. That's right. So that's it.